Earth, the only home we've ever known, and about as ideal as any we could wish for. A perfect planet for life, but doomed all the same.
While our planet is massive, it can only support so many members of rapidly expanding human populations. Even if we can't strike some sort of balance, we're still susceptible to cosmic catastrophes beyond our control, asteroid strikes, and the eventual explosive death of our sun. With no other star systems for light years, the long-term future of the human race seems uncertain at best. After all, surpassing the speed of light is impossible. But, in order to escape our solar system, we don't have to shatter the laws of the universe. We only have to bend them.
Reaching distant planets seems an impossible task when considering a direct point A to point B approach. To make it possible, we have to take extra spatial dimensions into account. Though we appear to live in a three-dimensional universe, the prevailing theory among physicists is that several other spatial dimensions exist, but that they are compressed and thus invisible. Our universe appears three-dimensional in the same way that this paper structure appears two-dimensional when flattened. We can't visualize jumps from the third dimension to the fourth, but it's easy to understand jumps from the second to the third. Imagine someone in a two-dimensional universe is given the ability to access the third dimension at will. What could they do with this power? What if the person was trapped in a two-dimensional prison? With walls on all sides, there's no way to escape, but by accessing the third dimension, they could easily jump directly outside of their cell. This amazing extra-dimensional person could perform even more impossible feats. If a wall blocked their way while making their escape, they could travel over it, an inexplicable concept in the second dimension. To onlookers, it would appear as if the person had traveled straight through the thick wall. And if cornered, the person could flee to the third dimension, thus disappearing completely. The pursuers can't look up, because they don't understand the concept of up. A fourth-dimensional entity, in our three-dimensional world, would have similarly fantastic abilities. But how does this relate to space travel? Suppose that, in a two-dimensional universe, a course has been plotted from Earth to Alpha Centauri, the nearest star system. In a straight line, the trip would take over 4 years, even traveling at the speed of light. But if the third dimension were used, the length of the journey could be reduced to almost 0. Likewise, traveling through space using the fourth dimension could allow us to escape our solar system. But isn't this model rather convenient? After all, our universe isn't actually bent like this. Or is it? From the perspective of the second dimension, it would be impossible to determine the three-dimensional shape of the universe. For all we know, it could look like this. Or this. Regardless, escaping the surface could allow for incredibly long-range space travel.
We're a long way from putting any of these ideas to practical use, but at least in theory, the fourth dimension looks like our best method of dodging the light speed limit. It's amazing to think that, far in the future, our descendants could look up at the night sky and see our own sun among the distant stars.
Our origin, but not our final resting place.